right, so I am going to help you guys with this Franklin article because it is kind of long and a little bit challenging. So prepare yourself for the Ben Franklin article, which you can look at if you want to. Maybe you could read it while I speak it, but it's a Ben Franklin article called Ben Franklin's Electrifying Experiments with Electricity, as read and interpreted by Miss Tarshis. So it starts. Ben Franklin's electrifying experiments with electricity. It was the mid-1700s, long after something called electricity had been discovered, but long before it would be put to practical use. No one quite understood electricity, but it fascinated everyone, including Benjamin Franklin. To Franklin, electricity seemed to flow, so he, like others of his time, believed that electrical energy was some kind of fluid. When someone touched or rubbed two things with an electric charge together, Franklin hypothesized that this fluid flowed from one thing to another. But the true properties of electrical energy remained a mystery. Then a friend from London sent Franklin something that helped him start to unravel the mystery. So one important thing to realize here is that a fluid that they're talking that Franklin thought energy was, a fluid is anything that flows. So that would be any liquid, water, pancake syrup, honey, soda, tea, anything like that, or gases. So the air that we breathe, carbon dioxide, that kind of stuff. So he thought that electric charge was a fluid, and that's how it's flowed. Yes. All right, next page. The wonderful bottle. Franklin received a, quote, wonderful bottle that could seemingly by magic store electrical energy. The Leyden jar, named after a town in the Netherlands, was a glass jar coated with metal foil and partially filled with water. A cork stuck in the neck of the bottle had a metal rod running through it and into the water. So what you can see in this image is the metal rod that starts here at the top, and then you have the cork, so the rod's here at the top, and then you have the cork, and then you can see the rod goes down the bottle into the fluid, and then that shaded area is supposed to represent the metal that goes around it. So Franklin held the jar so that the rod touched an object with an electric charge. Then the electric fluid from the object seemed to flow through the rod and into the jar where it was collected or stored. When Franklin made a connection between the rod and the jar's outer metal covering with a metal wire, zap, a spark. The energy inside the jar seemed to be released. So before he put the metal wire from the top to the side, there wasn't any zap. The energy seemed to be stored inside. This is important. When he put the wire on it, connecting the top to the side, he got the zap. Like electricity itself, this device puzzled people. Franklin conducted countless experiments with his Leyden jar. He observed that the metal rod, metal coating, and water of the Leyden jar were conductors, meaning electric fluid could pass through them. He also observed that glass was a non-conductor, meaning it would not allow electric fluid to travel through it. The glass of the jar, he concluded, was the key to storing the electricity. But how and why did the fluid move from one place to another? Just real quick, going over conductors and insulators. I'm sure most of you know this, but thinking that conductors are metal objects and insulators most of the time are non-metal objects. So plastic, wood, paper, and then that's like a roll of plastic. So sheets of plastic, and all the conductors there are metals. So bars of gold, which most of us have, and then it looks like metal drill bits, metal wire, a coil of metal wire, and then a package of metal wire. So just kind of thinking about that. There were conductors, things that move the electric current, and then insulators, things that don't. Positive and negative. Using the results of his observations and experiments, Franklin came to understand certain basic principles of electricity, which then helped him refine his model for the movement of electrical energy based on the Leyden jar. Franklin concluded that every object has a certain amount of electric fluid. An object that loses some electric fluid becomes electrically negative or minus, and an object that gains some electric fluid becomes electrically positive, or plus. For example, when the rod and the water inside the Leyden jar become electrically positive, Franklin observed the outer metal coating became electrically negative at the same time. The terms positive and negative stuck. Today, we use positive and negative to describe electric charges. And we now know that electrons, negatively charged particles that, along with protons and neutrons, make up atoms, can be transferred from one object to another. Positively charged objects have lost electrons, while negatively charged objects have gained them. Franklin also deduced that two positive objects repel each other, while positive and negative objects attract each other. The cloud, the kite, and the key. Franklin was not a man who missed much. He observed that the sparks created with the Leyden jar looked just like small bolts of lightning. He postulated, or hypothesized, that lightning was a huge release or discharge of electricity from storm clouds in the sky. To test his hypothesis, Franklin needed to go where the lightning was to find out where electric charges that could be somehow stored or built up and then released during a storm. The best way to get there, he decided, was to fly a kite during a storm. He made a kite with strips of cedar wood and a large silk handkerchief. He fastened a metal key to the kite string and attached a stiff metal wire to the top of the kite. What do you think Franklin predicted would happen when flying the kite in the storm? So if you think about it, he put a metal key there on purpose. He put metal on the top of the kite on purpose. So what do you think he thought? Then, on a stormy summer night in 1752, Franklin and his son William went to a small shed in the middle of a field. Franklin held onto a string as the kite went higher and higher. Nothing happened. He was getting discouraged when suddenly he noticed threads of the kite string standing up or repelling each other, a sign that the wire on his kite was collecting electric charges and they were flowing through the kite string. He touched the key with his knuckle and a small spark was generated. This showed him that electric charges were stored in the metal key and released when a conductor, his body, touched it, much like when the wire on the Leyden jar touched the jar's rod and the outer metal coating. Franklin had supported his hypothesis. Storm clouds were charged, and lightning was a huge electrical spark or release of built-up electrical energy. His experiment was a success in more ways than one. Why is it a good thing that a lightning bolt did not strike the wire on Franklin's kite? So think about it. It said that his body was a conductor. So if his body was going to conduct the electricity, what would have happened to his body? An ounce of prevention is worth a pound of cure. From various experiments, Franklin observed that pointed metal rods could, quote, silently draw off the electric fire. Franklin immediately set out to put his new knowledge to some practical good. In those days, lightning strikes often burned houses and barns to the ground. Franklin guessed that attaching a tall iron rod to a building would draw off lightning, which would then flow harmlessly to the ground. And he was right, again. Franklin's invention, called the lightning rod, saved many houses, including his own. So then what I have here is some pictures that I found on the internet. Here's a big barn that actually has 4 lightning rods across the top. And because it's not very clear on the picture, I gave you a little model, I guess, here on the bottom, showing the lightning hitting the lightning rod at the top. And then you can see that there's actually a cable from the bottom of the lightning that goes down the side of the house and into the ground. So that's how the energy from the lightning doesn't go through the house, but it actually goes through the wire into the ground. Busy, busy, busy. Like many scientists, Franklin published his findings. For example, he wrote Experiments and Observations on Electricity, which described all his work and findings about electricity. It became one of the most widely read science books of the time. The steps Franklin took to reach his conclusions were the same as those scientists use today. Faced with the question, he made careful observations and then used a model to explain his observations, make predictions, and develop a hypothesis. Then he experimented to test his hypothesis. His conclusions were based on the results of his experiments. So there's some discussion questions here, but I'm going to have you answer them in your notebook. You can go ahead and go back to the OneNote, and the questions are written there as well. Good luck.